First click Settings, then click 直通设计. Change the username to Wang Li Wen, and then log in. Click the 直通设计 again. An interface will pop up. Select the Yuan option. You can choose English, and then click OK. Next, click the red button to exit. Then click the lower right corner again to restart the educator. Then you can see a progress bar loading display in the bottom right corner. Until it reaches 100% loading, system language will switch to English.
What is now displayed is the main interface of the robot. Here you can check the power on time and program running time of robot. The current status of the robot can be seen at the bottom of the screen. Now you see is the programming interface program. You can write robot programs here. We can click Open in the upper left corner of the current interface to view existing program. For example, open a program at random, clearly see the complete steps for each procedure. Then click Config on the left side of the screen to set the current robot, such as the robot installation method TCP, and wait payload, initial pose and package pose. Click Move on the left side of the screen to come to the robot's mobile interface. You can adjust the robot's movement trajectory by controlling the buttons in the operating area on the right side of the screen. Now we are introducing the robot monitoring interface monitor at the top of this interface. You can select the module. For example, IOVAR can view the input and output status of the robot. Next is the log interface log0. This interface can view the power, current and voltage of the robot. Displayed on the right is the real-time temperature. The lower area of the interface displays the robot's alarm information, records, and other statuses.
First, log into the administrator account. The account does not have a password by default. Just click Login. After entering the programming interface program, click Move to add a movement instruction and add the number of waypoints according to the actual situation. What is shown now requires 3 waypoints. Add 3 waypoints in sequence. Now set the first waypoint, assuming that the first waypoint is the current location. Click OK to complete the first waypoint setting. Now to set the second waypoint, you can manually drag the position of the machine. After reaching the target waypoint, click Set Waypoint. And then click OK to save. The third waypoint is moved to a slightly lower position. Click Set Waypoint. And click OK. After completing all target waypoint settings, enter the program running settings. Click the triangular arrow in the upper right corner, then return to the initial waypoint. There are 2 different ways to return to the initial point. One is Move J, which is joint movement, and the other is Move L, which is linear movement of the robot after returning to the initial point. The move icon turns gray. Click Start to run the program. Click Graphics in the right area of the screen to see the robot's realistic movement trajectory. If the program needs to be paused, any waypoint location can be paused immediately. Click the Pause button again to resume exercise. If you need to stop, click the round square button in the upper right corner to stop the program. If you need to start the program, you must return to the initial waypoint again and restart. The robot has 2 different movement modes. Move J and move L. Move J is a speed unit in divided by S, and move L is in divided by S. The maximum movement limit of the robot arm is 3 meters per second. This Model G6 is 3 meters per second. The options are displayed here. A range is 0.01 to 3000 if we want to modify the current moving speed of the robotic arm. We can adjust the speed here. Now it is 250 millimeters. We can increase it to 1000 millimeters per second. After modifying the moving speed, the acceleration should also be adjusted to match it. Value adjusts to 2500 millimeters per second. Now click the triangle button in the upper right corner of the screen to run the program. If you want to increase the speed, just follow the above steps to modify the value. Now increase the speed to 2700 and 5000. At this time, let's take a look at its speed. Our robotic arm generally operates in 3 ways. The first way of movement is to check the TCP direction.
Using the right hand as a reference, the thumb represents C, the index finger represents X,
the middle finger represents Y, and Y corresponds to the cable direction of the robotic arm, which is also facing towards us. Press and hold E+. The robotic arm will move in the direction of the cable, while press and hold Y to move in the opposite direction. Holding down the X robotic arm will move in a left or right direction. Holding down B will cause the robotic arm to move up and down. In addition to the movement method of this robotic arm, we can also choose to directly input a TCP coordinate that we need. For example, we need a z-axis height of 200. After inputting, we can press and hold down to move the robotic arm directly to a position of 200 m. This 200 millimeters position is the height relative to the end flange and base of the robotic arm. The third way of movement is for us to move each joint individually. For example, moving the first joint alone in the positive direction. You can now see that the first joint is moving. The joint movement can be distinguished by the lid at the end. This is the first joint, second joint, third joint, fourth joint, fifth joint, and sixth joint. Each joint corresponds to a motor. The positive direction of the joint moves counterclockwise.
First come to the monitoring interface, where there is a track record. We click Start, and you can drag and drop. Click the Teach button, and then we drag the track casually. Then we can see that the point on our interface is increasing when pushing and pulling, which is equivalent to us recording this point. After we drag, click Stop, and it will let us save this trajectory. We name this trajectory 123. Click OK, and then save it. After saving, return to the programming interface. There is a template function here. We have a template function. Select Import. Import the trajectory we just named 123. And select OK. At this time, we click Start Run, and the robot will run the trajectory we just saved.
Now we are introducing the limitations of collision detection levels for robotic arms. If we need to increase the speed of the robotic arm, we need to lower the collision detection limit from most restricted to more restricted, less restricted, or least restricted. Next is joint limitation. The motion speed of a robotic arm is generally not set to a maximum value of 360 degrees. If we need to accelerate the movement speed of the robotic arm, we just need to set the maximum limit of the robotic arm's movement speed to 360 degrees. Then the joints of the robotic arm will reach the maximum speed. The speed of each robotic arm can be set separately.
We are now a move, and then we start moving. Now let's look at this image. We can see that this path is not very straight, because each joint of moves at a constant speed, the most comfortable posture of the robotic arm. If you need to move straight between points, switch move J to move L. After switching to move L, we click again to let the robotic arm move, so that we can see the straight movement between points.